This is my lathe. It's a Weiler LZ 330 from 1967. It's a very good German industrial lathe. As you can see, it has a digital readout, a so-called DRO. My dad once upgraded the machine with it. It works great and is a huge help when working. Both axes of the lathe are connected to the DRO, here on the X-axis and also the Z-axis. The hardware from the Z-axis is mounted back here. The DRO displays the position of the tool with an accuracy of 0.005 of a millimeter. As nice as everything is, I'm sometimes having issues with the one here from the X-axis. It's actually an optical scale. It uses a piece of glass with a precisely etched pattern which is inside this section, and it reads the exact position with a sensor which sits in here, which is attached to the top slide. The big issue with these optical scales is dirt. As you can see, it has a little seal lip in front of here, but dirt can still enter, and if you get dirt on the glass, the sensor will have issues reading its exact position. Once you get dirt in here, you need to disassemble everything, you need to clean everything, put it back together to get it back to working order. And this is very annoying and time consuming. I also must say that the mounting position of this linear scale is definitely not ideal, because it sits right below the working area where you have chips and cutting oil falling down all the time, and you often end up with dirt on the glass causing issues. But at the same time, I also must say that this is pretty much the only spot where you could reasonably mount it. Well, theoretically you could say, just mount it back here on the other side of the top slide. That's a very good position. You don't have the chips and oil here, but there's a very good reason it's not mounted right here, and that's because of the tailstock. Almost always, when using the tailstock, you need every millimeter of clearance. And you see how close you get right here. There's definitely no space to having the linear scale in between right here. That just does not work. Also, another issue with the optical scale right here is clearance under the chuck. If you have the jaws out a little bit to clamp a bigger piece, you quickly have clearance issues, as you can see. And this can be very, very dangerous. So repositioning the linear scale from the X-axis is no option, because it pretty much already is in its best location. It's just not a very good one. I got another solution for this problem. This is also a linear scale, which I can connect to my DRO. This is not an optical linear scale, it's a magnetic one. In here is a magnetic sensor, and this right here is a self-adhesive magnetic strip. You later mount them on the machine like so, with a little gap of air in between. And when you slide the reader on the magnetic strip, it can read its exact position. This is not just much smaller to install than the optical one, it's also much more resistant against dirt and oil and other stuff. So let's install this on my lathe, but first I need to take off the old one. Let's go. So, and that's it, the old linear scale completely removed. Now I can find a new place for a new one. At first I had the idea to attach the magnetic strip right here and add the magnetic sensor somewhere down here. But I quickly had to realize that this is not going to work out, because the magnetic reader has to be on the strip all along the maximum travel of the slide. And down here is just not going to work out. So that's totally maxed out. So we can see the end of the slide right here. So no chance to add the sensor somewhere in that range. So the sensor must be mounted somewhere in this area. This is too far back. Obviously, furthermore inwards would work out, but this will also interfere with the tailstock. If I'm now holding the sensor at that location and move the tailstock closer, I can see that the tailstock is now touching the sensor. So it gives less clearance, and that's definitely not what I want. Also, this clamping lever here is in the way of the sensor, and I don't really like that solution, so we need to find something different. So pretty much the only option is to add it to this side and mount the sensor somewhere in that area. So all I need to do is to add a little plate so I can mount the sensor in that location. So the magnetic strip is now completely installed, but there are two more things that I need to change. First of all, the magnetic strip is still right below the working area, so chips and cutting oil can still land on here, and I definitely don't want the magnetic strip to come loose because of dripping oil. Therefore, I'm going to use some seam sealer and seal this upper edge to get a nice and smooth transition. And the next thing I'd like to change is an embarrassing one for me, because I made a mistake when I made this plate. I forgot to add the thickness of the strip. And now these holes are too close to the strip and the sensor doesn't fit anymore. So I need to make a new plate with further distance to the strip. So everything installed and it looks really nice. Back here I attached the cable with a zip tie as drain relief. Also did some nice cable arrangement up here on the DRO with some zip ties. Only the final test remaining. Let's see if it actually works. And if it works, how accurate is it? So first I'm going to set the scale here to 0. Now I can set the DRO to 0 on the x-axis. Now I'm going to turn one full rotation back to 0. And now the DRO should show us 8 mm change in diameter. 8.000, exactly on the spot. Absolutely perfect. With this test right here, I want to see how accurate is the new linear scale on the full travel back and forth. We're here at one end of the top slide. I've set a dial indicator on it and put it on 0, and I also put the DRO on 0. Now let's see back and forth if we are at the same location. Dial indicator is here back at 0. And the DRO is at 0.1 millimeter, so 1/100th of a millimeter off at the full travel distance. Even though I had to move the sensor inwards a little bit, I still have no clearance issues at all with the chuck. As you can see right here, just putting in this jaw, it's now at the very furthest position outwards, and yet we still have no collision. It's very close, but you'll never ever use the jaws so far outwards. This one here is not even connected. This is a huge improvement, and I'm glad I finally made the upgrade. Thanks for watching.